Polygons and parallel lines. In this worksheet it's going to be important to remember all of your parallel line geometry rules, your polygon geometry rules, and so on. Let's begin. Here is a polygon with 7 sides, and I want to show the sum of the interior angles of the polygon is 900 degrees. Now in this question they've actually helped us out a little bit by splitting the interior of the polygon into triangles as a reminder of how this is done. When we want to find the sum of the interior angles, we now have 2 possible ways we can approach it. We can remember the formula. Number of sides minus 2 times 180 gives us the sum of the interior angles. So that's my formula. If I substitute into it, I'm going to have number of sides is 7 minus 2 times 180, and then I can do my nice job of working out that result. And that gives me 900 degrees. So there's our answer, 900 degrees. They are simply reminding us when they draw this diagram where this formula comes from. Each triangle that they've created is worth 180 degrees each. So, if I look at how many triangles there are, there's 5 of them, and that's 5 lots of 180, and that would get us the same result. So now we're going to apply the same principle to a question where we're not given the diagram. A regular polygon has 24 sides, and I want the size of one of the interior angles. I'm going to approach this question using exterior angles, just for the practice on exterior angles, and then show you how to do it with interior angles. So one of the most useful rules we have for any polygon is that the exterior angles all add up to 360 degrees, no matter how many sides there are. This is because exterior angles are formed by extending a side. And so each of these angles that we're creating is an exterior angle, and as we go all the way around, we'll do a full circle, making 360 degrees. It is also really important to remember that our exterior angles make a straight line with our interior angles. So over here, this interior angle is 180 degrees when taken with the exterior angle. If a polygon is regular, then every example of every different type of angle is the same. All the exterior angles are the same, and all the interior angles are the same. So a 24-sided polygon will have 24 exterior angles. They'll all be the same because it's regular. If I take 360 and divide it by 24, I will find the size of one of those exterior angles, 15 degrees. Seeing as that exterior angle makes 180 degrees with its interior angle, I can now subtract this from 180 in order to get 165 degrees for the interior angle. Now there is another way of doing this question. I can work out the total of the interior angles using that same formula I used before. So the sum of the interior angles is equal to n minus 2 times 180. Substituting in, the sum of the interior angles in this case is 24 minus 2 times 180. If I do the nice job of number crunching that result, I can get myself a sum for the interior angles. 3,960. If it's regular, then every one of those angles is the same, and there are 24 of them. I want to know one of them, so I divide by 24. So 3,960 divided by 24 into the calculator, and we get once again 165 degrees. Now we don't have a good approach and a bad approach, it's just whatever makes most sense to you. Let's move on. Now I want to calculate the size of one interior angle of a regular 12-sided polygon. So this is exactly the same question, I just have a different number of sides. Let's use the exterior angle method again, just for practice. If it's a regular polygon, every angle is the same. The exterior angles will add up to 360. If there's 12 of them, then 360 divided by 12, which gets me 30 degrees, works out the size of one exterior angle. Remember, exterior angles make a straight line with interior angles. So 180 minus 30 will give me the size of the interior angle, 150 degrees. And there we are. Remember, you could also use the interior angles sum formula, just as I did before. So here we have a diagram with a triangle on it. And the first thing you want to do when you get given a diagram with a bunch of lines and angles on it is look for what you know and what might be helpful. What rules do we have that might apply to this situation, without worrying too much about how to work anything out? Well, I definitely think that the 180 degrees in a straight line rule is going to be useful here, and I think that the 180 degrees in a triangle rule may be useful over there. In fact, if I take my 180 degrees in a straight line rule, I will quickly realize that x is equal to 180 minus 120, which is 60 degrees. Whenever you find something out, add it to your diagram, because it's going to help you find out other things. They're all stepping stones on the way to the next thing we want to work out. So in this case, of course, I can look at my diagram and say there's 180 degrees in that triangle. The 80 and the 60 between them make 140, so 180 minus 140 will give me the value of y, 40 degrees. So x is 60 degrees and y is 40 degrees. And there's our solutions. Next question. The interior angle of a regular polygon is 171 degrees. I want to work out how many sides the polygon has. Now once again I'm going to use the exterior angles because it's a very useful rule. Remember, whatever my polygon is doing, my exterior angle out here and my interior angle in here are on a straight line, so they add up to 180 degrees. If the interior angle of my regular polygon is 171, then the exterior angle must be 9 degrees. I know my exterior angles will eventually make 360 degrees, so I need to work out how many 9s I need to make up 360. This simply means doing 360 divided by 9. 360 divided by 9 gets me 40. So 40 9s makes 360. That means we need 40 exterior angles, which means we're dealing with 40 sides. This approach is far more straightforward than trying to reverse engineer the interior angles formula, so that's the approach I'm going to stick with. And I'm going to get into the next set of solutions in the next video.